Okay, in case of X bar and S, so for X bar here also we are considering the sample average. We are going to add all values within a sample or within a subgroup, and we are going to divide it by sample size, that is n. Okay, we will get X bar and we are going to plot those values on the chart. In case of S, we are considering sample standard deviation. Okay, if you consider sigma, that is the process standard deviation, S is the sample standard deviation. Okay, in the syllabus copy they specified this chart as X bar and sigma. Okay, so that is also part of this chart only. Okay, so X bar and S is the proper name. Okay, so even you can, if in the exam if you get X bar and sigma, okay, you have to plot the same graph. Okay, so same charts. S is the sample standard deviation. Generally, X bar and S charts are preferable. So for these cases, if the sample size is large, that is greater than 10 or 12, okay, so then we prefer X bar and S charts. The sample size n is variable. Okay, so even for X bar and R chart, so there's one more condition, that variable sample size, which we have not covered. Okay, so that also can be used, but this X bar and X charts are preferable in case of variable sample size, that is n is variable. Traditionally, quality engineers have preferred the R chart to the S chart because of the simplicity of calculating R from each sample. Already you know the procedure to calculate R. Okay, you have to find out maximum and minimum value, you have to take the difference. That is a very simple procedure. Whereas in case of finding this S value, you need to for calculation it requires more time, it will consume more time and it will require more effort. Okay, so that's why, so earlier quality engineers were not preferring to use X bar and S chart, but now the availability of calculators and also softwares, okay, so even X bar and S charts can be implemented because calculation can be reduced. So with the help of softwares, they will do calculations automatically based on the inputs. Okay, that is also possible now. So we are able to overcome this disadvantage of manually calculating S values, which is complicated compared to calculating R values. Next, construction and operation of X bar and S charts. The sample standard deviation S is not an unbiased estimator of S. That means if we try to get the value of S, okay, that is not accurate value of standard deviation. Okay, so if the distribution is normal, then as S actually estimates C4 sigma, where C4 is a constant that depends on the sample size n. Okay, there is some error with the direct calculation of S. So actually what we are able to get from that is, so we are able to get C4 sigma, okay, where C4 is the standard that we can obtain from table 6. Okay, the standard deviation of S is given by this sigma root of 1 minus C4 square. This information can be used to establish control charts on X bar and S. So the 3 sigma control limits for S are, so this is the central line C4 sigma, that is nothing but S. So this is the upper control limit and this is the lower control limit, and we are considering 3 sigma control limit, that means plus or minus 3 sigma. Okay, so here since standard deviation is given by this, so instead of sigma we are considering sigma root 1 minus C4 square. So here also, and this is the equation used to find S. Okay, so compared to finding R, this is complicated because so you have to consider all 5 values one after the other, you have to add them by comparing with the sample average. Okay, so that is a complicated procedure, or that will require, even if it is not complicated, it will require more time than finding range. Okay, and these previous equations of upper control limit and lower control limit, so this can be simplified like this. Okay, so in the equation, okay, so C4 3 root of 1 minus C4 square. Okay, so this can be written as B5. Okay, so here if you take sigma common, then remaining will be C4 minus 3 root 1 minus C4 square. Okay, so that can be written as one more constant called B5, which you can get from the table. Next, again here also C4 plus 3 root of 1 minus C4 square. Okay, that can be written as B6. So same equation you can reduce it into, so B6 sigma, then central line will be C4 sigma, and lower control limit will be B5 sigma. Okay, so these are the control limits, and so this is applicable only when you know the value of the sigma. But in most of the problems, you don't know this value of this sigma. Okay, that's why. So these are not useful in the point of view of this course. Okay, so for that we make use of one more set of equations. Okay, if sigma is not given, then it must be estimated by analyzing past data. Suppose that m preliminary samples are available. So these are the number of different samples, or it is the number of subgroups. Okay, suppose that m preliminary samples are available, each of size n, this is the sample size, and let Si be the standard deviation of ith sample. The average of the m standard deviation is given by this S average. Okay, so that means first you have to find out individual sample values, individual sample deviation values, S value. Then you have to add, if there are 25 different subgroups or different samples, then you have to add S value of all 25 divided by 25, that will give you S bar. Next, the statistic S bar by C4 is an unbiased estimator of sigma. Therefore, the parameters of S chart would be, so S bar, this is the center line, plus, so instead of sigma, so you are using S bar by C4 in the previous equation. Okay. So since in the beginning, okay, so we consider for S, we are going to get C4 sigma. That means S will be equal to C4 sigma. Then sigma will be S by C4. Based on that, so you have this, okay, S bar by C4. Next, again, this equation can be simplified by taking so S bar as common. Okay, so take S bar as common, and then again, so you will get, so 1 minus 3 by C4 root 1 minus C4 square. Okay, so then this can be written as B3 S bar, since B3 is this one. Okay, next, again similarly, this equation can be simplified like this, B4 S bar, where B4 is, so you have to take S bar common, then 1 plus 3 by C4 root of 1 minus C4 square. So this is equal to B4. That is a constant that you can get from the table. Okay. Note that B4, again B4 can be written as B6 by C4, B3 can be written as B5 by C4. Okay. Next, so this is the equation which we are going to use to find limits. Okay, so this you have to remember: upper control limit, lower control limit, and central line. Okay, so this we are going to use in our calculations. Okay, and in plotting X bar and S chart. Next, so here you need equations to find control limits for X bar chart also. Okay, so for that, these are the equations. Okay, mean value will be same. So this is the process average. Okay, so X double bar. Next, so we have 3 sigma limits. Okay, plus or minus 3 sigma limits. So we have this equation. Again, this can be simplified. So if you consider 3 by C4 root n. Okay, so this can be written as A3. So this will become X double bar plus A3 S bar. So this is the central line, then A3 S. So in order to plot X bar and S chart, okay, you should remember only this much. So these are the equations to find control limits for X bar chart, and these are the equations required to find control limits for S chart. Only these two are sufficient. Okay, and one more equation to find S. So okay, this equation. So only these things are required. Remaining just for understanding the concepts. Okay, need not worry about those things. So just remember the equations related to plotting control charts. So we can understand this with the help of a problem. So table presents the inside diameter measurements of forged automobile engine piston rings. Each sample or subgroup consists of 5 piston rings. Construct and interpret X bar and S charts using the piston ring inside diameter measurements. Also estimate process standard deviation. Okay, so here we have statistic regarding dimension. Okay, that is diameter of the engine piston ring. Okay, so based on that, so we have to plot X bar and S chart. Then we have to say whether the process is in control or out of control. Then we have to estimate process standard deviation. Okay, so this is given in the problem. Along with this problem statement, this table also will be given. Okay, again, so there are 5 samples. So there are 25 different samples within each sample. So you are taking 5 trials. Okay, while measuring the dimension. Okay, you are taking 5 trials. So that is the meaning. In the same sample, you are taking 5 trials for measurement of the diameter of the piston ring. Next, so here also same procedure. You have to find out X bar. So for finding out the X bar, sample average procedure is same. So you have to add all 5 values, divide by 5. You will get X bar value for sample 1. Similarly, add these 5 values or divide by 5. You will get X bar value for sample 2. Like that, find out X bar value for all 25 samples. Okay. Next, by using the equation of S, you have to find out S value for every sample. Okay, so that we will discuss in detail. Okay, so this is the equation used to find out X bar. Add 5 values, divide by 5, you will get X bar. Next, after finding X bar, we can find out X double bar by adding all X bar values of 25 samples, divided by 25 will give you X double bar. Then using this equation, you should find out S values for all samples. Okay, for example, if you want to find out S value for sample number 1, then so Xi means that particular trial value. Okay, so for if you are starting from left side, okay, 74.030 minus X bar value. Okay, whatever value that you are going to get after adding 5 and after adding 5 values and dividing it by 5. Okay, that value you have to substitute here. Then square plus second value minus X bar, third value minus X bar, fourth value minus X bar, fifth value minus X bar. Then for this case n will be 5. Okay, that will give you S value. That I will explain by considering all those values. Okay. Next, after finding individual S values, so you have to add all 25 values, divide by 25, you will get S bar. Okay, these X double bar and S bar values are required to find out control limits. Okay, so this is the equation to find control limits for X bar chart. Okay, so if you know X double bar, that is the central line. Okay, then next, if you want to find out upper control limit, so then A3, that is available in the table for N5, you will directly get from table. S bar value you will get here. Okay, using that you can find out upper control limit and lower control limit. Similarly, if you know S bar value, you can find out control limits for S chart also. These are the equations. Okay, these equations are required to plot control charts for X bar and S. Remaining not required. You must be concerned about these equations. Next, so as I told you, so the procedure to find out X bar is same as what we did for X bar and R chart. Okay, same concept. Add all 5 values, divide by 5, you will get this value. Okay. Next, after that, add all 25 values, so you will get this number 1850.028. So then divide that by 25, you will get 74.001. This is X double bar. Next, you have to find out S bar value. In order to find out S bar, you need S value. Okay, so after getting S value for all 25 samples, So you can add this value, divide by 25, you will get this S bar value. Okay. Next, so I will explain how to get S value, this one. Okay, so compared to finding R value, finding this S value will consume time. Okay. So first, so this is the equation. First you should know X bar. Okay, so first find out X bar. For this, X bar value is 74.010. So X bar value will be 74.010. Next Xi. So you have to add, you have to do summation of these two differences. Okay, square of difference of Xi and X bar. So first consider 74.030. Okay, so again it is a root. Okay, root of Xi is 74.030 minus X bar 74.010, then whole to the power square. Next plus, consider second value 74.002, again minus, same X bar value will remain same for sample number 1. It is same for all the 5 trials. Okay, next 74 for third one, 74.019 minus 74.010 whole to the power square. Next 73.992. Since you have to add all the values, so plus. Okay, after this you have to add them. So again last one, 74.008 minus 74.010 whole to the power square. Next n will be 5. Since sample size is 5, our number of trials you are considering is 5. It is 5 minus 1. Okay, so then you will get 0.0147. In the similar way, you should find out S2, that is S value for sample number 2. Our sample standard deviation for sample number 2. Okay, so same procedure. So instead of, so here 73 root of 73.995 minus 74.001, then whole to the power square plus 73.992 minus 74.001 whole power square. Like that you have to find out. Yes. So now you will understand. So why quality engineers were preferring R charts over S. Okay. Finding S value will consume time. If it is not done automatically using a software, okay, it will consume time. Even in order to calculate using calculator, okay, so you need to enter so many values, and again there's a problem of committing errors while typing these values on the calculator. Okay, so these are the consequences with finding S values. Okay, like this you have to find out S value for all 25 samples. Okay. Next, after getting these values of X bar and S for all 25 samples and finding their averages, you can go for plotting control chart. Okay, first find out upper control limit and lower control limit. Okay, so in this case, so first you can plot X bar chart only. In case of R and X bar chart, so usually R chart will be plotted first, then we go for plotting X bar. Whereas in case of X bar and S, there is no such restriction. You can plot X bar chart first only. Okay. Next, so this is the equation for upper control limit of X bar chart. Okay, use this equation. Already we know X double bar is 74.001. Substitute that value. A3 you will get from the table. Okay. So here it is sample number 5. Okay, we want A3. This is the A3. So for 5, this is the value 1.427. So here we took 1.427. Okay, in the exam also you can use this table. Okay, you should take printout of this table and you can make use of it in the exam. Okay. So next, then S bar value also we determine. So that is 74.014. Okay, so next, so X double bar, same this value. Okay, next lower control limit. Similarly, you find you will get this. So after getting control limits, so go for plotting X bar chart. Okay, it's totally 25 samples. So on X axis, sample number, it should be 1 to 25. Okay. In previous class, I explained in detail. I have shown the procedure using SolidWorks. Okay. Same procedure you have to follow. There is no new concept regarding plotting charts and plotting points and connecting them using straight line. Procedure is same. Okay. First draw x-axis and take sample number on x-axis. So 1 to 25 numbers you should write. Then on y-axis, so look at the values, okay, which is the minimum value and which is the maximum value. So then you will get an idea regarding, so what scale you need to take so for y-axis. Okay. First consider maximum and minimum values in this column. That is one thing. Then also consider the values of upper control limit and lower control limit. Okay. So upper control limit is 74.014, lower control limit is 73.988. Okay. So now you can take 0.005. Okay, so as the S1 unit, 0.005 difference. Okay, here you can see 73.985. Since it should include 88, okay, it should be 985. Then consider a difference of 0.005. So you will get 990, then 995, then 7400, like that. So maximum value will be 74.014. So if there are points beyond the control limits, you may be having beyond that. For that reason only, you should evaluate maximum and minimum values on the column of X bar and also upper control limit and lower control limit. Then only you will get a clear idea regarding what values you need to plot. Okay, so then you can decide on these things. Okay, then plot the value. So after deciding on taking scale, okay, 1 unit equals how much, so then you can go for locating the control limits. Okay, first lower control limit 73.988. so here 73.98, draw a horizontal line. Then 74.001, so consider that point, draw a horizontal. Then 73.988, okay, so 74.014, that is the upper control limit. So consider this and draw a horizontal line. Okay. So after drawing that, so you can name it as lower control limit and you can write that value. So here central line or x double bar, you can write that value. So upper control limit, you can write that value. Okay. Then so you have to go for locating the points. So first one is 74.010 for sample number 1. 74.010 for sample number 2, 74.001 for 3, 008 for 4, like that you have to plot these values. Okay, then after plotting these values, then look at the pattern. If there are any points beyond the control limits, okay, then you can say the process is out of control. Or sometimes you can apply the patterns also. Okay, or if you can go for applying the concepts of run. If there are more than 8 points, okay, on upside or downside of the central line, okay, then also you can comment on that. Okay, otherwise the process will be in control. In this case also the process is in control because all points lie within the control limits. Next, similarly, so plot S control chart, that is sample standard deviation control chart. S is nothing but sample standard deviation, whereas sigma is the process standard deviation. Okay. So here, so for n, so you need B3 and B4 values that you can get from the table. Again, for sample size 5, B3 and B4 values you can get from the table. So B3 0, B4 2.089. Okay, so here you can see, so those values were substituted. B3 0, B4 2.089. Okay, again using this equation you can find out upper control limit and lower control limit. Again same procedure. So look at the difference between maximum. Look, I try to find out maximum and minimum value in this column. Then once again look at the upper control limit and lower control limit. Then so you will get an idea regarding what values you need to consider on y-axis. Okay, so then you can take your 1 unit as 0.05. Okay, 0.05, then 0.01. So here you can consider 0.15, 0.02, 0.25, then 0.03. Okay, so you can consider any convenient units for plotting graph. It is not an issue. Okay, anyhow the pattern of the control chart will remain same. Okay, so here also, so after plotting S control chart, okay, so all the points lie within the control limits. So that means here also there is no indication of out of control. Okay, that means you can conclude that. So since all the points on X bar and S chart, okay, so lie within the control limits, the process is in statistical control. Like that you can conclude. Okay. Next in the question, so they asked one more question. Estimate process standard deviation. Okay, for estimating process standard deviation, we make use of this equation. Sigma bar, that is estimate of process standard deviation, is given by S bar by C4. Again, this is the value of S bar. C4 you will get from the table for sample size 5. Okay, so here you can see, so for sample size 5, C4 value is 0.9400. Okay, you will get from the table. So since as I told you, both the charts, so points fall within the control limit, the process is in control. Okay, so so I will give one more problem. Okay, so later after completion of the third module, so I will give assignment. In that assignment, I will include this question also. Okay, so in a similar manner, you should plot X bar and S chart for this problem. Okay, then if the points are within the control limits, process will be in control. If you get points outside the control limits, then process is out of statistical control. That you can conclude. Okay. Next, applications of variable control charts. Okay, in the textbook, so they have considered few case studies where they make use of these control charts to address some problems. Okay, so these three are there in the textbook. You can read. Okay, if you are interested, you can read. So one is they have applied control charts to improve suppliers' processes. That means in that case, there is a company which is procuring aerospace components from 2 suppliers, and after procuring, so they are receiving defectives. Okay, then after they did evaluation of the quality using control charts, X bar and R charts. Okay, and they were able to give suggestion to the suppliers. Okay, implement statistical quality control techniques, tools. Okay, so that you can reduce the number of defectives you are manufacturing. Like that, they gave suggestion. That case study you can observe. Okay, next, to purchase a machine tool. Even to make a decision regarding purchasing a machine tool, also companies, one of the company, they make use of these charts. Even this is one of the non-manufacturing application. That means it is an application in finance sector. Okay, where they used control charts. Okay, so to evaluate the time taken to do a financial transaction. Okay, it may be regarding processing a check. Okay, so or making a payment. So for that also these control charts can be used. Okay, so these are the case studies. Okay, there are so many applications. So these are only few examples given in the textbook. Okay, so this completes